Now, in the next one, we want to find out the area enclosed between the curve and the line. So what we have to do really is, first of all, we need to know the points of intersection, which you've been asked for in part one. And then we can get the area under the curve, which would be the whole thing. And then from that, we're going to take away the area of the triangle underneath. And that should give us the area of the shaded region. So to get their points of intersection, I literally just need to let them equal one another. Now this one is written as y equals 2. So the first thing I'm going to do is rewrite the linear to be y equals 2. So I'm going to just move the x over 12 minus x. The linear is 12 minus x over 3. Now, so therefore that's y equals 2. This is y equals 2. So to find out where they meet, I'm literally just going to let one equal the other. So I'm going to allow him to equal him. So this is us just finding our point of intersection. So cross multiply then, so it's going to be 6 times this guy and 3 times this. Now, when I go to multiply that out, I get 72 minus 6x is equal to 72 plus 30x minus 3x squared. Now, putting that together, we have 3x squared minus 36x equals 0. So just use my null factor theorem here, and I'm left with x minus 12. So I end up with x is 0. So 3x is 0, which means x is 0, and x is 12. Now, because Q is on the x-axis, so that's going to be our 12, no, sorry, Q, yeah, sorry, we're going to fill back in for our y, but because it's x, we know that this one has to be the 0 because it's on the y-axis. And in this one, the x part is 12. So we don't have our y parts. We do need the coordinates of them as well. So it does ask us for coordinates. So if I put 0 in the place of x, I end up with 4. So I'm just putting, what I mean by that is if I put 0 in there, I get 12 minus 0 over 3, which is 4. And then if I was to do the same with the 12, I would just end up with 12, take 12, which is 3, which is 0, which makes sense because it's lying on the x-axis anyway. So there are coordinates. And then, of course, to find the actual shaded region, I need to do the integration between 0 and 12 for the curve. Now I'm going to actually write that as 1/6, and then I'm just going to write the rest of it in a bracket because when I go to integrate that, it's not very, it's not written the way I'd like it to be. And then from that, I'm going to take away the integration. Well, I'm going to take away the area of the triangle. Now you could take a shortcut here, actually. Instead of using integration, we could just do half base by height because it's half of 12. And I know the height is actually 4. So I know that's 24. So if it's a right angle triangle, you can use, your half base by perpendicular height, or you can integrate. It's up to yourself. Now, if for the first part, obviously I have no choice. I have to integrate this because it's a curve. So you don't really need to worry about the 1/6. So we can just leave that there for the moment. So this is going to become our 24x plus 10x squared over 2 minus x cubed over 3. And of course, all of this is going to be between 0 and 12. So let's see, we might multiply in the 6th. Actually, it might make it a little bit easier. So I think we'll do 4x plus, this is going to be 10x squared over 12. And then we're going to have minus x cubed over 18. And then we'll put in the 12 and the 0, and we're going to take away the 24 when we're ready. So that's 4 times 12 plus 10, 12 squared over 12 minus 12 cubed over 18. Now, if I then fill in the 0, that's just all going to become 0. So we're minusing away 0. And then from all of this, we're minusing away 24. So we end up getting, that ends up becoming 72 minus 24. So we end up with 48 units squared as the answer of the shaded region.